Okay, guys, we're going to talk about arithmetic sequences. Okay, and a sequence is when you have a sequence of numbers. It might look something like this: 2, 5, 8, dot, dot, dot. An arithmetic pattern is when you add or subtract the same amount to get to the next number every single time. So in this case, what's happening is we're adding 3 every time. So if I wanted to talk about the next number in the pattern, it would be 11. So let's get rid of this. The next number in the pattern will be 11, then 14, then 17. The pattern will continue. We're adding the same thing every time. Okay, so when we want to write an equation for this, all right, there's a formula that looks like this, which means the nth term in the sequence. And you would do the first term plus the nth term minus 1 times d, this is called the common difference. And I'm not going to spend too much time on this because when you do this, it all works out to be a linear equation. So you can do it in slope-intercept form. So we're going to simplify this, okay? Instead of wasting all our time with this, what we're going to do is we're going to find the, we're going to find the common difference. Okay, we know it as the slope, how much it's changing by every time. So we'll call that, I'm going to just call it like this. We're going to write it like it's y equals mx plus b. And instead of writing the m, we're going to use the variable n because that's what we do in a sequence. Okay, this is still the slope, and this is still the y-intercept, or I'm going to call it the 0 term. Okay, so it should look like this. And it's pretty straightforward. So if I want to find the nth term for this particular sequence, I'm going to find the slope or how much it's changing by every time. And if you take a look, it's changing by 3 every time, plus 3, plus 3, plus 3. That's what we call the common difference. And so we're going to plug that in right here for m, the common difference, and we're going to multiply that times n. Then we have to find the 0 term. In the slope-intercept form, we usually call that the y-intercept, but the 0 term is, let's take a look. This one's going to be the first term. First term, second term, third term. So to find the 0 term, you always just go back one term. So from 2, instead of adding 3, I'd subtract 3, and I'd find this term right here. This is going to be my 0 term, or what I'm going to call the y-intercept. And I'm just going to plug in -1. And that's how we would do a sequence. So if I asked you for something that looks like this is just a notation right here. And that notation is that I'm looking for the 25th term in this sequence. So what I would do is plug in 25 for n and solve. So 3 times 25 is 75, minus 1 is 74. So the 25th term, I would write it like this, the 25th term equals 74. All right, so we're going to do another one just so we can make sure we have a good handle on it. All right. Let's do one with a negative. Okay. And then I'm going to show you what's not an arithmetic sequence just so you can see the difference. So the next one, let's say the next pattern goes like this: -25, -28. Well, actually, let's use a different number. Let's do -30, -30, -35, dot, dot, dot. All right, so we have this sequence, and you want to take a look at what's happening. So if you look, each time we're subtracting 5. That's our slope. So if we were writing y equals mx plus b, we would just plug in -5 for our slope. And so far, it looks like this. Okay? Now we need the y-intercept, which means I need the 0 term. And I'm always giving you, when I give you a sequence, this is always the first term, second term, third term. So if I want, I can always go back one term to what I call the 0 term, or the y-intercept. And so instead of subtracting 5, I'm going to add 5, and I would have -20. You can see how that would follow the pattern. And so that would be my y-intercept. And that's how you would write it. Now I'm going to turn it into sequence. So it looks like an arithmetic sequence. So instead of writing Y, I'm going to write A with a little subscript of N. That's the notation that we're doing a sequence here. And instead of writing X, I'm going to plug in N, and it looks like this. So if I want the 20th term here, I'm going to plug in 20 for N. So it looks like this. And then I would just do out the math, and I would do -5 times 20, which is -100, minus 20. So the 20th term would equals -120. And that's how we would do an arithmetic sequence. Now, I'm just going to point out really quickly that there are other types of sequences. Okay, so you might have something like this. Clearly, there's a pattern happening here. But if you take a look, we're not adding the same amount every time. What's happening is we're multiplying by 2. And we'll come to this later on. This is not an arithmetic sequence. It is a geometric sequence because we're multiplying by 2. So in order for it to be an arithmetic sequence, you have to be adding or subtracting the same amount every time. It can't be multiplication or division. It has to be addition or subtraction. And that's all you need to know really about arithmetic sequences.